Hi everyone, so today's video is a recap of what we talked about and investigated in class today. Very proud of your efforts today in investigating the square root function. So as a reminder, just as a review from class, the parent function that we investigated was y equals the square root of x, called the square root function. Could also be written as f of x equals the square root of x. Using function notation. And we talked about this general equation, kind of like playing a game of Tetris. It moves left, right, up, down, gets wider, narrower, and flips over the x-axis, and even could flip over the y-axis. So as a reminder, the value of a, tells me that there could be a shrink or a stretch. Okay. If it's greater than 1, it's going to be a stretch. If it's a fraction less than 1 but greater than 0, it's going to be a shrink. H is going to move the graph left or right. And we investigated that with Desmos and talking through, and we noticed that it was actually always moving in the opposite direction of the sign, okay? But it was moving along the x-axis, left or right. And that k on the outside was moving the graph up or down. But every time we did that, we always went back to what was the original parent graph, the mama bear, and that was the square root function. I want you to think of HK kind of like we did when we did this with the vertex of a parabola. The parabola, that HK changed the vertex. It moved that vertex left, right. This one, because it's the square root function and has a distinct starting point, in this case right here, okay, it's going to shift that starting point left, right, and then every other point on the graph. And we investigated some of those points, 1, 1, 4, 2, 9, 3, those perfect squares. All right, now there are 3 ways that we can actually graph a square root function. I'm going to show you all 3, but in this video I'm only going to review 2, and we're going to do the last one together in class. So the first way is using translations and writing a rule. And we did investigate and talk about that, and you've been using that idea all year. And then the other way we're going to talk about is using the graphing calculator or Desmos if it's available. Okay? All right, so let's talk about translations using the parent graph. So I look at this and I notice that I have a square root function and it's being shifted. And hopefully you see that the H is shifting. It's shifting to the right 3 and up 2. You might not see that, but hopefully you'll be able to identify the parent function. So y equals the square root of x. All right, to translate that, we have to think about what's happening and write a rule that we're going to apply to all the x's and the y's on the graph. Okay, so in terms of this rule, we know that inside the function it changes the x, meaning it's going left or right, which is the x-axis, and on the outside that k is going up, down. So in this case, if I asked you to write a rule, I think you all are pretty comfortable with the rule being x. We're going to add 3 to all the x's, and we're going to add 2 to all the y values. Well, what points are we going to do that to? All right, so if I want to use a translation, we are going to take our parent function, y equals the square root of x, and we are going to put in the points that we talked about in class today. Those points were all perfect squares starting at 0. So we plugged in 0, 1, 4, and 9. And the output on the parent graph of those were 0, 1, square root of 4 was 2, and the square root of 9 was 3. All right, now we're going to make a new table applying the rule to the parent graph. So in this case, we would have x plus 3 and then y plus 2. And all we're going to do is to all of these x's, we're going to add 3. So 0 plus 3 gives me 3, 1 plus 3 gives me 4, 4 plus 3 gives me 7, and 9 plus 3 gives me 12. All right, and then all my y values, I'm going to add 2 because I'm shifting it up 2, and those y's are along the y-axis. So 0 plus 2 gives me 2, 1 plus 2 gives me 3, 2 plus 2 gives me 4, and 3 plus 2 gives me 5. So I'm going to actually plot those points now. 3, 2, 4, 3, 7, 4, it's right here, and then 12, a little bit farther, 12, 5, so maybe right about here. And there is my square root graph starting at now 3, 2, because it's shifting the parent graph to the right 3 and up 2, and that starting point that was at 0, 0. So I'm going to put the other graph on here because I want you to see it. So here's 0, 0, 1, 1, 4, 2, and 9, 3. Think about that. Did I shift the graph to the right 3 and up 2? And I did. And that's the translation of the graph. Now remember, the domain is the x values that we're allowed to actually kind of plug into this function that will make it a number that I'm able to graph. And our domain in a square root function comes from this part, okay? Now, looking at the graph, it's easy to see that this graph starts right here at 3, so my domain has to be from there greater. So my domain would be x is greater than or equal to 3, which in interval notation we would say hard bracket 3 to infinity. And the range, remember, is those y values. You know, my graph's getting yucky, so let me erase a little bit of that. Oops, sorry guys, what happened? What did I do? My y values start here at 2, and the y values are increasing ever so slowly, but they're going to go all the way. They're going to have every y coordinate on the graph as well. So my range would be y's greater than or equal to 2. And so we would write that as hard bracket 2, infinity. All right, so hopefully that kind of makes sense, so we're going to try one. So here's our graph. I look at it, I see that the parent function is y equals the square root of x. So I'm going to write y equals the square root of x. Now I only see an h, so my rule is only going to affect my x's. So my rule would be in this case, remember it's always opposite, so x minus 5 comma y, because the y's, there's no k, the y's are not going to change. I'm going to make my tables. My first table is the y equals the square root of x graph, and those are the points that I know I love to plug in. 0, 1, 4, 9. I'm plugging in my perfect squares. My outputs are going to be those roots, okay? So 0, 1, 2, and 3. Now I'm going to apply my rule. I'm going to make a table with my rule, x minus 5 comma y. So I'm going to subtract 5 from each of those x values. That means it's going to shift it to the left 5. I think those would be the points, and the y's are going to remain the same. So 0, 1, 2, and 3. So 0 minus 5 is negative 5. 1 minus 5 is negative 4. 4 minus 5 is negative 1, and 9 minus 5 is 4. I'm going to plot those points. So negative 5, 0, negative 4, 1, negative 1, 2, and 4, 3. And there's my graph being shifted to the left 5 units. All right, so I'm going to ask you to do is to try this last one, y equals the square root of x minus 8. I'd like you to identify the parent, plot the points on the parent function, write your rule, and apply your rule. And then I'd like to see if you can give me the domain and the range. Now we are going to go back to that last one for domain and range in class. All right, so then let's look at the second method, okay, the graphing calculator. Now I want to remind you that on those graphing calculators, you have the y equals, okay? So I'm going to get my graphing calculator up, and that would be TI. Sorry about that, not having this up, guys. Okay, and then I'm going to go to my y equals. Okay, and let's see, you can't see this, can you? Okay, so I'm going to go to y equals. So if everybody could do that, you can see y equals, you're going to put in the function, so 3, remember second function, down here 2x squared, there's that square root of x, 3 square root of x. We use the x button that is in the second column, and then we have to get out of the square root to do plus 1 that's on your sheet, plus 1. And if we go to the graph, we can see our graph. And you can see that it's been shifted. It actually looks like it's also been vertically stretched towards the y-axis, so it's gotten a little bit like closer to the y-axis. Maybe it's increasing a little bit faster. Now, I might want to look at my table here. So I'm going to look at the table feature, and I'm going to go to my table. Okay. Now, you can see on my table that I have some random numbers in here, and these aren't going to be the table values that I want to for me to plot points. So I'm going to go to my table setup, okay, and you can see that mine is on ask, and I'm actually going to change it to auto because I really would like this to be on auto, and I want my table to start at 0 and I want it to go up by 1. The reason that is I really want to see the points on this graph. So look what happens. When I go to my table, I can see that at x of 0, I have a 0.1. At x of 1, I have a 0.4. And at x of 4, I actually have a 0.7. And x of 9, I have a 0.10. These I'm probably not going to use at 2 and 3 because those are so not great numbers. So then I can write down my points, 0, 1, okay, 1, 4, 4, 7. Okay, so 1, 4, and 4, 7. That's for this graph. And I'm going to plot them. Okay, so 0, 1, 1, 4, and 4, 7, right about there. And there's my graph using the graphing calculator. All right, the domain, if you want to think about this domain from the graph, it starts at 0 and goes to the right. So x's are going to be greater than or equal to 0, and you know that because even just looking at the equation, my range is going to start at that value of 1, 0, 1. So it's here going up forever. So that's the range is going to be y's greater than or equal to 1. And again, you should be able to write those in interval notation. So 0, hard bracket 0, comma, infinity, and 1, comma, infinity. All right, guys, I'm going to stop there today. You might want to try this next one on the graphing calculator, see if you can do it, and then we're going to talk about it in class tomorrow. Thanks so much. Have a great night.